All right, so today we're going to talk about finding the distance between any 2 points. And so with these points here, both the green point, the red point, and the blue point, we can find the distance between them. So if I want to find the distance between this red and this blue point, I can count just like I would at any game, board game. So 1, 2, 3, 4, 5. I count the spaces. That's 5 spaces. If I want to count the distance between the red and the green point, again I count 1, 2, 3, 4, 5, 6. That's 6 spaces. Now what if I want to find the distance between the green point and the blue point? Well, we can't just count because this is not a value of 1. And actually, if we look, if I connect these dots and these distances, you can kind of see I made a right triangle. So how do we find this distance of the right triangle? It's a hypotenuse. So if we say that this is c squared is equal to a squared plus b squared, that's Pythagorean theorem, which may look familiar. So c squared is equal to 5 squared plus 6 squared. So c squared is equal to 25 plus 36. So c squared is equal to 61. So that distance must be the square root of 61, which for, just estimating purposes, if we wanted to get a decimal approximation about that, that's about 7.8. So it's in the ballpark of 5 and 6. Now, this is how we're going to be calculating distance between points, and we're going to be using a specific formula for distance. So if I have these 2 points here, -8, -4, so 1, 2, 3, 4, 5, 6, 7, 8. I think I count that right. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. We have this point here, and that's going to be y. And then we have P is 4, 1, and that is point P. We want to find the distance between these 2 points there. Now, unfortunately, we cannot just count as we did for the previous example. So instead what we're going to do, we're going to make this a right triangle. We're going to make this distance the hypotenuse. And so if I draw this line and extend it out and draw downward from P, you can see I have now this right triangle. And now I can count these distances. So I can count 1, 2, 3, 4, 5. That's a distance of 5. And then I can count this distance. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is a distance of 12. So the hypotenuse must be 5 squared plus 12 squared, and then take the square root of that. So distance yp is equal to the square root of 5 squared plus 12 squared. So that is the square root of 25 plus 144, which is the square root of 169. And that is a perfect square, which is 13. So that distance yp is 13, which is nice to think about. So we can really make right triangles from any of these. However, to draw this out and to count would be a lot of work. We could get this without needing to graph and count points. And we can do that by what's called the distance formula. Now, if I just look back at this real quick, this distance here that I got 5 from, notice that that's a vertical difference. That's the change in the y value. So that is y2 minus y1. Likewise, over here, this is a horizontal difference. This is a change of x2 minus x1. So if I wanted to calculate 5 squared, in this case, that's really y2 minus y1 squared. And 12 squared is x2 minus x1 squared. So for the distance formula, it's going to be the square root of the change in the y values, so y2 minus y1 squared, plus the change in the x values, x2 minus x1 squared. Again, we can see that this difference in the y and the difference in the x give us these legs of this right triangle. So actually, let's do that and let's see if we get the same answer. So looking here, the distance between these 2 points is going to be y2, which is 1, minus y1, plus x2, which is 4, minus x1. So we get 1 minus negative 4, which is 5 squared, plus 4 minus negative 8, which is 12 squared. Well, that's exactly what we had before. We had 5 squared plus 12 squared. So we know that that's going to be the square root of 116, or 13. And that's using the distance formula. Here, for this question, we can again use the distance formula. So if I want to find the difference between these 2 points, I don't need to count. Distance is going to be equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. So distance is going to be equal to the change in y, so 6 minus 1 squared, plus the change in x, which is 2 minus a negative 3 squared. So distance is going to be equal to the square root of 5 squared, plus this is another 5 squared. That's the distance is equal to the square root of 25 plus 25, which is 50. Now, unfortunately, 50 is not a perfect square, unlike 169, which gives us a square root of 13 as an integer value. 50 does not do that. So instead, what we need to do is we need to reduce this. We can't convert it to a decimal because, unfortunately, decimals are inaccurate. They're rounding off, and we want the exact value. So what we can do is we can reduce the radical, and here we have the square root of 50. So what we can do is we can look for factors that are perfect squares. So the square root of 50, well, 50 is 25 times 2. So that means that the square root of 50 is the square root of 25 times the square root of 2. Well, the square root of 25 is 5, and the square root of 2 is root 2. Now, technically, the square root of 50 or square root of 25 is plus or minus 5, but we just write the positive. If we take this second square root, then we could do it differently. And of course, if we're talking about distances, we're only going to have positive roots because we can't have negative distances. 200 we can break down because 200 is 100 times 2. So again, it must be the square root of 100 times the square root of 2. And the square root of 100 is 10. So we simply get 10 square root of 2. And this is the acceptable answer. So for the previous question with the distance formula, the square root of 50, we would actually write that distance is equal to 5 root 2. So if we want to find the distance between these 2 points, we could also do that. So I'm going to do that here. And so distance is the change in the y values, so y2 minus y1 squared plus x2 minus x1 squared. So distance is going to be equal to 9 minus 0 squared plus 5 minus negative 7 squared. So distance is going to be equal to 9 minus 0, which is 9. Squared is 81. 5 minus a negative 7 is 5 plus 7, which is 12. So 12 squared is 144. Now if I add 144 and 81 together, I'm going to get the square root of 225. And that actually is a perfect square. So distance is equal to 15. So it works out in that case. We don't need to reduce this radical. For number 2, we have that, again, y2 minus y1 squared plus x2 minus x1 squared. We have the change in the y values, so 6 minus 3 squared, plus the change in the x values, 4 minus 1 squared. So 6 minus 3 is 3. 3 squared is 9, plus 3 squared, another 9. Get the distance is equal to the square root of 18. Now here we have to reduce this. So we can say that square root of 18 is actually the square root of 9 times the square root of 2, which we actually saw before. Square root of 9 is 3. So we get as our final answer 3 root 2. Now if you want to check this, you can put in your calculator 3 times the square root of 2 and the square root of 18. You will get the same decimal for both of them. And finally, we want to talk about midpoint. Distance and midpoint usually go together. And if we look at these 2 points here, what's halfway between them? Well, if we count the spaces, 1, 2, 3, 4, 5, 6, that means I'm going to go 3 from either direction. So from this point, I go 1, 2, 3. And from this point, I go 1, 2, 3. So this is the midpoint. So this red point here, this looks like it's 2, 1, 2, 3, 4, 5, 2, 5. This point looks like it is 8, 5. And so that means 2, 3, 4, 5. This point is 5, 5. Now, just like the distance formula, we can't always count. So instead of counting, there's another helpful formula to help us out, and that's called the midpoint formula. Midpoint formula, very simply, midpoint formula, very simply is this. It's going to look like 2 points, and it's the sum of the x values divided by 2 over the sum of the y values divided by 2. So for this example, don't want that little dot there. So for this example here, look at the x values. 2 plus 8 is 10. 10 divided by 2 is 5, which we get here. The y values, 5 plus 5 is 10. 10 divided by 2 is 5. So we actually get this from the midpoint formula. We don't need to count. And here are some examples of that. So if I want to find the midpoints, the x values here, this is going to be negative 9 plus 5 over 2, comma, the sum of the y's, 3 plus 7 over 2. And this is going to give me negative 9 plus 5 is negative 4. Negative 4 divided by 2 is negative 2. 7 plus 3 is 10. 10 divided by 2 is 5. That's the midpoint between these 2 points. For the second one here, I do the sum of the y's, so negative 12 plus negative 8 divided by 2. The sum of the y's, sum of the x's divided by 2, sum of the y's divided by 2. Negative 12 plus negative 8 is negative 20, divided by 2 is negative 10. And negative 7 plus negative 4 is negative 11. So I actually leave that as negative 11 halves. Again, improper fractions are perfectly okay. For number 3, I add the x values, 3 plus 5 divided by 2, and I add the y values, 1 plus 3 divided by 2. This gives me 3 plus 5 is 8, divided by 2 is 4, and 1 plus 3 is 4, divided by 2 is 2. And finally, this last one, if I add the x values, I get negative 4 plus 5 divided by 2. If I add the y values, I get 2 plus negative 2 divided by 2. So this is going to give me 1/2, again leaving that as a fraction. And here 0 divided by 2, which is just 0. So that's the midpoint formula. And it's somewhat easy to calculate, hopefully. Just don't forget it. And it's a lot easier than counting, just in the way that using the distance formula, while it looks intimidating, it's a lot easier than having to go through graphing points and counting them and drawing right triangles. And make sure that you understand how to reduce radicals appropriately and not write them as decimals.